Dear viewer, thank you again for tuning into my channel, The PPO Theory. My name is Peter and you are more than welcome. Now this is the fourth video in the series, and this is going to be about entanglement. I'm going to do it a bit different more. I'm going to use the green board more and also redraw it a few times for your convenience. And I'm going to improvise more because, you know, I know all the arguments by heart. So first, what I want to show you is that entanglement, the proof of entanglement is hinged on our interpretation of what it means, what polarization means, so how a polarization filter works. You know, the Nobel Prize Committee have given Clauser, Aspect and Zeilinger the Nobel Prize for having proven that entanglement exists. Well, I'm going to show you first how their reasoning goes, and what belt-type experiments are in that context, and then I'm going to show you an alternative interpretation of polarization, and I hope to convince you that this alternative explanation is just as valid as, or even more valid than, the explanation of Clauser, Aspect and Zeilinger. So in that, I'm going to use my book. They are going to impersonate particles. So this is a particle with a spin up, and this is a particle with a spin down, as you can see. Now, they are going to approach a polarization screen, and this polarization has a polarization orientation strictly vertical, as you can see. So now this book also has a polarization orientation strictly vertical. It's just going to get through. If it is on the hand horizontal oriented like this, it will be blocked. If on the other hand the angle is a bit like so beneath 45 degrees, somewhere here, there is a probability of it going through or not. So it has to throw a dice. This particle has to throw a dice, and the dice will decide whether it goes through or not. There's probability involved. So now then there is a problem if you have two particles going through that same filter, or two separate filters. If they both go through and they are entangled, so then this one has to throw a dice and this one has to throw a dice, and the outcome would be random if there is no coordination between the two. So if there is no communication or whatever interaction between the two, none whatsoever, you would see random outcome. So this one throws a dice, this one throws a dice, this one goes either through, this one goes either through or not. But in reality, and that is what these experiments of Clauser, Aspect and Zeilinger show, there is some coordination between the two. So if this one goes through, that one also goes through. So in a manner of speaking, they both have to throw the same dice. Now that's strange. So there is a coordination between the two. And you could then argue, for example, well, okay, so this one, there's a signal going from this one to that one, and so they tell each other what to do. Well, okay, that since we think that those type of signals that we are talking about then can only move with the velocity of light, so we can exclude them from having any influence, showing that the time between the two measurements here and there does not permit for any information to go hand and foot, because that would need a superluminous time travel of information, and that's impossible. So we are left with the only explanation, that's what they say, that there is some sort of coordination between those two particles going through the polarization filter, and that coordination we call entanglement. And the type of experiment that I just showed is called belt-type experiments. Many of these experiments have been done, and the experiments of Clauser, Aspect and Zeilinger is only one of them. But it is also the latest, and they say, oh, that experiment is so very good and precise and doesn't contain any loopholes anymore, so they get this Nobel Prize for it. So now I'm going to rearrange the board a bit so that I can show you an alternative interpretation of polarization. So bear with me. So here I am again in real life speed, and I have these two particles again, and this time I've drawn a polarization filter as I think it is, namely it has a polarization area. It does not have this small slit where particles have to go through. No, it has a polarization area. And if this particle angle is within the polarization area, it will certainly go through. If on the other hand it is outside of the polarization area, it will certainly not go through, it will be blocked. And another rule of polarization is that when it goes, this book goes through the polarization filter, when it comes out, it can have various angles of polarization, as long as it is within the polarization area of the filter. So we do not have this polarization beam, because a beam is a sort of train of particles that come out of the polarization filter. We currently, physicists think that all these particles coming out of the filter are all in line, have exactly the same polarization angle. I disagree. We can also think about all particles coming out of it having this having a polarization angle within the polarization angle, polarization area of the filter. So that is the difference between how I look upon polarization and current belief in how polarization works. And this makes a lot of difference. Yeah? I'm going to show you by just rearranging a bit. So remember that I have now a situation where these two particles enter the polarization filter and they come out within the polarization area. And they can only enter the polarization or get through if their angle is within the polarization area. So now let me redraw the situation a bit again. So here we are again, and I have redrawn the situation so that the angle of orientation of this polarization filter has shifted some 45 degrees. So now remember that these particles that went to the first filter came out within the orientation area of the first filter. So you now see that many of these are within the polarization filter of the second filter. They are within the polarization area of the second filter, you see. And those that are within, they will certainly go through without having to communicate with each other, without having to throw any dice at all. They do not have to throw a dice for themselves, because they know exactly, well, when I'm oriented within this polarization area, I will go through. And this one has the same situation. When it is within the polarization area, it will go through. And so we do not need any coordinated mechanism, and we do not need entanglement. So again, the argument is that many of those particles that came through from the first polarization filter, they have a polarization that is within the polarization area of the first filter. Yeah? And so many of them will also be within the polarization area of the second filter. And though it would seem that there is some sort of coordination because they both go through the second filter or both are blocked by the second filter, but in this explanation you see that we do not need any form of entanglement at all to explain what is happening. We only need another interpretation of what polarization exactly means. So, you've heard my argument, this is it. A more elaborated version, of course, of my arguments you can find here in this book. Look it up in section 4.1, a download link is below. Well, I'm happy to hear from you if you are in agreement or disagreement with my arguments. Please share your reactions and your views below this video. And thank you for tuning in. I hope to see you next time. Don't forget to give me a thumbs up if you liked it and subscribe to my channel. And of course, resend this video on all the platforms that you use. I hope to see you next time. Bye bye.